In this video, we're looking at first principles of differentiation. First part of our question says use first principles to derive the gradient function of the equation y equals 3x squared minus 4x minus 2. We know that the first principles formula is f dash of x, which is the gradient or the derivative, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over the top of h. So we're going to work out what the numerator of this formula should be, and we'll substitute that in. We start by writing f of x. So our function is 3x squared minus 4x minus 2. And we follow this by the function evaluated at x plus h. So everywhere in our original function that there's an x, we're replacing it with x plus h. So we have 3, there's an x, so we replace it with x plus h squared. Minus 4, there's another x, so we replace it with x plus h minus 2. So let's go ahead and expand and simplify this a little bit. If you can remember the expansion for x plus h squared, you can go ahead and pop that in and skip a few steps, but we'll work through the long way of expanding using the FOIL rule. So 3x plus h multiplied by x plus h minus 4 times x is minus 4x. Minus 4 times h is minus 4h. Take 2. So we can expand this double bracket as x squared plus hx plus hx plus h squared minus 4x minus 4h minus 2. If we collect our like terms, we've got those two hx terms in the middle. So that's x squared plus 2hx plus h squared minus 4x minus 4h minus 2. And finally, we can expand that coefficient of 3 out to the bracket, which gives us 3x squared plus 6hx plus 3h squared minus 4x minus 4h minus 2. And there are no like terms, so we can't simplify that any further. Our third step is to write f of x plus h minus f of x, which is what the numerator of our formula will be. And this is equal to our f of x plus h function, 3x squared plus 6hx plus 3h squared minus 4x minus 4h minus 2. And from that, we're going to subtract. I might just change the color here so it's easier for us to see what we're subtracting. We're subtracting the original f of x function, the original function, which is minusing off 3x squared minus 4x minus 2. Pop that in brackets to remind us to subtract each part of that expression. And so we have 3x squared. I'm just copying down the original, the f of x plus h function. And I'm going to expand out those brackets at the end in red. So we have minus 3x squared, which would be take 3x squared, minus negative 4x, which would be plus 4x, and minus negative 2, which would be plus 2. And now we can see if we simplify this, we have 3x squared, take 3x squared, that'll cancel, minus 4x plus 4x, and minus 2 plus 2. And as we expect, every term from that f of x function, the original red function, has cancelled, which is what we hope will happen each time we calculate f of x plus h minus f of x. And so that leaves us with 6hx plus 3h squared minus 4h for our numerator of the formula, which we can now go and we can substitute in. So we have the limit as h approaches 0 of the numerator has become 6hx plus 3h squared minus 4h all over the top of h. Now, to be able to evaluate the limit, we need to not have that h on the denominator because we can't have a 0 as a denominator of a fraction. So we take a common factor from the numerator because I can see that h is a common factor. And that leaves us the remaining factors of 6x plus 3h minus 4 over the top of h. And now we can cancel those two h's. And we're left with no h on the denominator, which means we'll be able to evaluate our limit. So that's 6x plus 3h minus 4. So now we go ahead and evaluate the limit by setting h to 0. So that becomes 6x plus 3 times 0 minus 4, or just 6x minus 4. So we've solved part A. We've derived the gradient function of the equation y equals 3x squared minus 4x minus 2. And that gradient function is 6x minus 4. Now we want to look at part B. I'm going to clear away the rest of our working out here, so if you need to see that, you can go back and you can pause the video. But our original function I will keep, 3x squared minus 4x minus 2, we'll keep that original function. And we will keep the derivative, which we worked out. The derivative of the function, f dash of x, was 6x minus. So part B is asking us to determine the gradient of the function where x equals 3. So what that's asking us to do is to evaluate our gradient function, because we know that this function will give us the gradient at any x value. Instead of evaluating it at x, we want to do it at the value of 3, f dash of 3, which means everywhere there's an x in our derivative function, we want to substitute in 3. So we have 6 times 3 minus 4, which is 18 minus 4, which is 14. So that tells me that the gradient of the function, gradient of the function f of x is 14 at x equals 3. Part C asks us to determine the value of x when the gradient function is 0. So it's asking us to take our gradient function, f of x, and make that equal to 0. It's not the x that is 0 this time, it's the whole function. So if we pop our gradient function in there, we get the equation 6x minus 4 equals 0. And we want to determine the x value that makes our derivative or our gradient 0. And so we solve this equation by adding 4 to both sides. We have 6x equals 4. And we're left with x equals 2 over 3. So what that tells us is the gradient of our function, or the derivative of y equals 3x squared minus 4x minus 4, is 0 when x is 2/3, which tells us that's a point where the gradient is 0.